US Physics Olympiad, year 2014. F equal MA, first round. This round consists of 25 problems for 75 minutes. All solutions for these problems you can find in the description reference below this video. Please subscribe for this channel. In that case, you will have opportunity to get many interesting Olympiad level and other hard level problems in physics. Problem 1. A car turning to the right is traveling at constant speed in a circle. From the driver's perspective, the angular momentum vector about the center of the circle points x and the acceleration vector of the car points y. What is the direction of x and y? Problem number 2. A ball rolls without slipping down an inclined plane as shown in the diagram. Which of the following vectors best represents the direction of the total force that the ball exerts on the plane? Problem 3. An object of uniform density floats partially submerged so that 20% of the object is above the water. A 3 Newton force presses down on the top of the object so that the object becomes fully submerged. What is the volume of the object? The density of water is 1000 kilograms per cubic meter. Problem number 4. What are the correct values of the numbers in the following statements? Assume there are no external forces and take n equal 1 to mean that the statement cannot be made for any meaningful number of particles. If a particle at rest explodes into n1 or fewer particles with the known masses, and the total kinetic energy of the new particles is known, the kinetic energy of each of the new particles is completely determined. If a particle at rest explodes into n2 or fewer particles, the velocities of the new particles must lie in a line. If a particle at rest explodes into n3 or fewer particles, the velocities of the new particles must lie in a plane. Problem number 5. A unicyclist goes around a circular track at radius 30 meters at an amazingly fast constant speed of 10 meters per second. At what angle to the left or right of vertical must the unicyclist lean to avoid falling? Assume that the height of the unicyclist is much smaller than the radius of the track. Problem number 6. A cubical box of mass 10 kg with edge length 5 meters is free to move on a frictionless horizontal surface. Inside is a small box of mass 2 kg, which moves without friction inside the box. At time t equals 0, the block is moving with a velocity 5 meters per second directly towards one of the faces of the box, while the box is initially at rest. The coefficient of restitution for any collision between the block and box is 90%, meaning that the relative speed between the box and the block immediately after a collision is 90% of the relative speed between the box and the block immediately before the collision. After 1 minute, the block is at displacement x from the original position. Which of the following is closest to x? Problem number 7. A 1 meter long stick with a uniform density is allowed to rotate about a point 30 centimeters from its end. The stick is perfectly balanced when 50 gram mass is placed on the stick 20 centimeters from the same end. What is the mass of the stick? Problem number 8. An object of mass m is hung on a vertical spring or spring constant k and is set into vertical oscillations. The period of this oscillation is t0. The spring is then cut in half and the same mass is attached and the system is set up to oscillate on a frictionless inclined plane, making an angle theta to the horizontal. Determine the period of the oscillations on the inclined plane in terms of t0. Problem number 9. A 5 kg object undergoes a time-varying force as shown in the graph below. If the velocity t equal 0 seconds is positive 1 meters per second, what is the velocity of the object at the time t equals 7 seconds? Problem number 10. A radio-controlled car is attached to a stake in the ground by a 3 meters long piece of string and is forced to move in a circular path. The car has an initial angular velocity of 1 radian per second and smoothly accelerates at a rate of 4 radians per second square. The string will break if the centripetal acceleration exceeds 2.43 by 10 power 2 meters per second square. How long can the car accelerate at this rate before the string breaks? Problem number 11. The point mass m is connected to an ideal spring on a horizontal frictionless surface. The mass is pulled a short distance and then released. Which of the following is the most correct plot of the kinetic energy as a function of potential energy? Problems 12 and 13. The following information applies to questions 12 and 13. A paper helicopter with a rotor radius r and weight w is dropped from a height h in air with a density of ρ. Assuming that the helicopter quickly reaches terminal velocity, a function for the time of flight t can be found in the form of t equal this expression, where k is an unknown dimensionless constant, actually this one, alpha, beta, gamma, and omega are constant exponent to be determined. Questions. Question 12. Determine alpha. Question 13. Determine beta. Problem number 14. A disk of a moment of inertia I, mass m and radius r, has a cord wrapped around it tightly as shown in the diagram. The disk is free to slide on its side as shown in the top-down view. A constant force of T is applied to the end of the cord and accelerates the disk along a frictionless surface. After the disk has accelerated some distance, determine the ratio of the translational kinetic energy to total kinetic energy of the disk. Problem number 15. The maximum torque output from the engine of a new experimental car of mass m is tau. The maximum rotational speed of the engine is omega. The engine is designed to provide a constant power output P. The engine is connected to the wheels via a perfect transmission that can smoothly trade torque to speed with no power loss. The wheels have a radius r. and the coefficient of static friction between the wheels and the rotors mu. What is the maximum sustained speed v the car can drive up a 30 degrees incline? Assume no frictional losses and assume mu is large enough so that the tires do not slip. Problem number 16. An object of mass m1 initially moving at speed v0 collides with an object of mass m2 equal alpha m1, where alpha less than 1, that is initially at rest. The collision could be completely elastic, completely inelastic, or partially inelastic. After the collision, the two objects move at speeds v1 and v2. Assume that the collision is one-dimensional and that object 1 cannot pass through object 2. After the collision, the speed ratio r1 equal v1 over v0 of object 1 is bounded by next inequalities. Problem number 17. A spherical cloud of dust in space has a uniform density ρ0 and a radius r0. The gravitational acceleration of free fall at the surface of the cloud due to the mass of the cloud is g0. A project occurs heat expansion that causes the cloud to suddenly grow to a radius 2r0, while maintaining a uniform but not constant density. The gravitational acceleration of free fall at a point r0 away from the center of the cloud due to the mass of the cloud is now next one. Problem number 18. Consider the following diagram of a box and the two weight scales. Scale A supports the box via a massless rope. A pulley is attached to the top of the box. A second massless rope passes over the pulley. One end is attached to the box and the other end to scale B. The two scales indicate the tension TA and the TB in the ropes. Originally, scale A reads 30 newtons and the scale B reads 20 newtons. If an additional force pulls down on scale B so that the reading increases to 30 newtons, what will be the new reading on the scale A? Problem number 19. A helicopter is flying horizontally at a constant speed. A perfectly flexible uniform cable is suspended beneath the helicopter. Air friction on the cable is not neglectable. Which of the following diagrams best shows the shape of the cable as the helicopter flies through the air to the right? Problem number 20. A crew of scientists has built a new space station. The space station is shaped like a wheel of radius r, with essentially all its mass m at the rim. When the crew arrives, the station will be sent rotating at a rate that causes an object at the rim to have radial acceleration g, thereby simulating Earth's surface gravity. This is accomplished by two small rockets, each with a thrust T newtons, mounted on the station's rim. How long a time T does one need to fire the rockets to achieve the desired condition? Problem number 21. Two pulleys shown in a figure are made of the same metal with density ρ. Pulley A is a uniform disc with radius r. Pulley B is identical except a circle of r over 2 is removed from the center. When two boxes M equal alpha M, where alpha greater than 1, are connected over the pulleys through a massless rope and move without slipping, what is the ratio between the accelerations in system A and B? The mass of pulley A is big M plus small m. Problem 22. A body of mass big M and a body of mass small m, much less than big M, are in circular orbits about their center of mass under the influence of their mutual gravitational attraction to each other. The distance between the bodies is r, which is much larger than the size of either body. A small amount of matter delta m, much less than small m, is removed from the body of mass small m and transferred to the body of mass big M. The transfer is done in such a way so that the orbits of the two bodies remain circular and remain separate by distance r. Which of the following statements is correct? Problems 23 and 24. The following information applies to questions 23 and 24. A 100 kg astronaut carries a launcher loaded with a 10 kg bowling ball. The launcher and the astronaut's spacesuit have negligible mass. The astronaut discovers that firing the launcher results in the ball moving away from her at a relative speed of 50 meters per second. Question 23. What is the impulse delivered to the astronaut when firing the launcher? Question 24. The astronaut in the previous situation is now moving at 10 meters per second as measured in a certain frame of reference. She wishes to fire the launcher so that her velocity turns through as large angle as possible in this frame of reference. What is this maximum angle? Hint: a diagram may be useful. Problem number 25. A block with mass m is released from rest at the top of a frictionless ramp. The block starts at a height h1 above the base of the ramp, slides down the ramp and then up a second ramp. The coefficient of kinetic friction between the block and the second ramp is nil. If both ramps make an angle of 30 with the horizontal, to what height h2 above the base of the second ramp will the block rise?